So this is day 137. We're going to talk about equations of parallel and perpendicular lines. Parallel lines are lines that never touch, right? Okay, perpendicular lines cross at how many degrees? 90, right? Does that make sense? It's a right angle. Yes? Okay, cool. So when I put this on graph paper, we're going to talk about how do we make parallel lines on graph paper, and how do we make parallel lines on or perpendicular lines on graph paper. That's the goal for today. So since we're going back to lines in graph paper, what is the slope-intercept form of a line, everyone? Okay, good. So y equals mx plus b, and what does m stand for, everyone? Slope, and slope is really what? Okay, what's b then? Y-intercept. Okay, remember how to graph all this from before? Okay, so we're going blast from the past. We're going back to some October, November stuff and before, okay? Ready? So, I won't be able to record this on the video, but on Desmos, put these 4 lines into Desmos. We're going to do this as a class, so everyone's pulling out their Desmos, and if you're on the video, please pause here and please put these 4 lines onto Desmos. What do you notice about the lines? What shape do they all make together? A square or a rectangle, right? So how many degrees are each angle? 90. Are they right?
Yes.
Okay, good. Now, meaning right angles, 90 degrees. So what about the opposite sides? Are they parallel or not?
Yeah.
Okay, cool. Which lines are parallel? Let's look up here at our 4 original lines. Okay. When I look at these 4 equations right here, which ones are parallel then? We have 4 of them. 1, 2, 3, and 4. Which are parallel?
1, 3, 4.
Okay, good. So 1 and 3, and you said also which one?
2 and 4.
Good. Would you all agree with that?
Yeah.
If they're parallel, what similarities do you see between the 2 parallel lines, or between each set of parallel lines? Yeah, Amber. Good. Do you notice that the slope here is the same for both of these? Let's focus on the first and the third equation. You see how these 2 slopes are the same? What's the slope on the first and third equation? Good. Okay, now let's look at the second and the last equation. What's the slope on those? And -3/2, right? Cool. So what do we know about parallel lines then? What assumption can we draw? They have the same slope, okay? Does that make sense? Okay, cool. Now you said there's also 90-degree angles. Let's compare the second or the third and the fourth one. What do you notice about the 2 slopes? What's similar and different about them? To your neighbors, and what do you notice about the third and the fourth slope here? What do you notice? What makes them perpendicular? How do you get a perpendicular slope? I'm seeing some people turn their hands and I'm hearing opposite. Okay, I got a question. What's similar and different about these last 2 slopes? Okay, one slope is negative, and then what else do you do to it? Oh, the numbers are switched, like flipped, right? What's that math word called when you flip a fraction? Reciprocal. So when you watch, so then a parallel slope are the same slope. Okay, parallel lines have the same slope. Perpendicular slope has a reciprocal or a negative reciprocal, right? Does that make sense? Okay, so I'd like you to write 2 statements down. These are the 2 things you're learning today, and it's super easy after this. So the first statement is, parallel lines have the same slope. Okay, parallel lines have the same slope. And the second statement is perpendicular lines have a negative reciprocal slope. I need both of these statements in your notes, okay? Same, okay? I'll give you 1 minute. Let's pause the video here. Moving forward here. Okay, so we already know what a slope is. We know that parallel lines have the exact same slope. And I talked to you about slope-intercept form here on the bottom right, okay? Here's one thing from the past that I want you to write down is point-slope form. You need to know how to use this when we want to create a new line. with a point and a slope. So let's please put these two in your notes, the point slope form with the equation. 30 more seconds, last thing you have to write here, and then we're going to get into the lesson here. Okay, here we go. So, today we're going to only deal with parallel lines, just so you can see the process. And this is blast from the past, October, November stuff, okay? So you can do this. What do we know about parallel lines again? What kind of slope do they have? What was that again, Celeste? Okay, what do we know about parallel lines? Everyone, what kind of slope do they have?
Exactly.
Okay, exact same slope. Okay, cool. So I'm going to read this out. Write the equation. This is the directions up here. Write the equation of the line in slope-intercept form that is parallel to the given point. Okay? So the key word here is parallel. You see that? So because of that, I'm going to think about what Celeste said. What kind of slopes are parallel slopes? Again, everyone?
Exact same thing.
Okay, good. All right. Very good. All right. So looking up here, you got y is equal to 5x plus 1. So we got a slope here of 5, right? So the first thing I want to do, I want to show you is that you're going to be graphing, like on a test. I want you to graph the original line. So from before, the y-intercept here is 1. Slope is 5. So just when we graph the original line, we're going to put our y-intercept at 1. And then I'm going to go count up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 over 1. And we're going to plot a point here, and we're going to keep going counting and plotting a point, and in both directions I'm going to draw a line. Okay? So this is the original graph, okay? We want a line that's parallel to it, and saying, hey, we want it to also cross this point, negative 1, 2. So we're going to go negative 1, 2, and plot a point. So we want a line that is parallel here, okay? So, how do I do that? Do I just take my ID card and draw a parallel line?
Yes.
No, I want to know the exact line, okay? There's like a noise in there. Do you hear that? Okay.
It's the
Okay, so how do we get this parallel line here? The first thing you want to do is you want to start with the slope, point slope form. So it's y minus y1 is equal to m times x minus x1. So what is our y1 and our x1? Remember over here, here's our x and our y. Our x is supposed to be negative 1, and our y is supposed to be 2. So I'm going to start writing this down. We got y minus y1, which is 2. I'm going to bring that down, is equal to our slope of 5. We want the same slope, right? We'd put a 5 here. Now, just quick question. What if we wanted the perpendicular slope? What would you have put instead of 5, everyone? How do you get a perpendicular slope? How do you make 5 a fraction? Okay, what's the reciprocal of 5 then? How do you make a negative? Put a negative sign in the front. So what's the reciprocal slope, everyone? Okay, good. Negative 1/5. Thank you. Huh? Well, that's what we're going to do tomorrow, right? So this is the difference from today and tomorrow is that this is 5 today. It's the same slope. Tomorrow it'll be the negative reciprocal. All right, so we got to continue on putting our x. Our x1 is, what's our x1 on this problem? Negative 1. We're going to put that in there. Okay, and we're going to multiply across. So 5 times x is 5x. And then 5 times negative, these two negative signs becomes a positive sign. So we got 5x all plus 5 is equal to y minus 2. I'm going to add 2 to both sides, so y is equal to 5x plus 7, okay? And that's your final answer here, okay? Am I done yet? No. Let me prove to you that this graph, when I graph this new line, it'll be parallel. So our y-intercept look over here is 7. So I'm going to put 7 down as my y-intercept. I'm going to put a second point up here by counting up 5 over 1, and I'm going to go down the opposite way. Now look what happens when I go the opposite way. I go down 1, 2, 3, 4, 5 over 1. And hey, look at that. What do you notice about this point here, everyone? It's already there. Isn't it on the line? Good. That means we did it correctly. And then we would graph, and we would be done. Okay? So are these lines parallel? Yeah. So did we do it correctly? Yeah. Okay, cool. So let's do a little math chatting, and I'll show you another one, okay? So really quick, let's go, since it's Tuesday, talk really quick about number 1. How did I just do it? Ready, set, go. Thank you for talking. Here's number 2 now. I'm going to do it one more time. We want a parallel line to this one. So on number 2, we got y is equal to 3/4 x minus 2. So I'm going to plot this on my graph really quickly. Okay, so I want a graph that's parallel to this line here, okay? And it's supposed to be on a point -2, 1, okay? So, what's the slope of number 2, everyone? 3/4, right? A parallel slope would be then what? Parallel slopes are the same or different?
Same.
Okay, cool. So what is the parallel slope here that we want?
3/4.
Okay, good. Some people were saying 4 over 3.
Who said that? I said negative.
Okay. So what is a perpendicular slope to 3/4?
Negative 4 over 3.
Okay, good. Just want to make sure. That's for tomorrow. But today we're going to do parallel. So I'm going to take that parallel slope, 3/4, and I'm going to start with the point slope form. Y minus y1 is equal to m times x minus x1. And I'm plugging my x and a y in my slope, which is the same. And when I do that, I got some fractions I deal with now. Okay? So I know that these two negatives here become a positive. So now we're going to multiply. 3/4 times x is 3/4, but now we have 3/4 times positive 2. Oh boy, I'm going to have to do a side problem. I'll do it up here on the side. Right, I can make 2 a fraction, and I could cancel 4 and 2, making them 2 and 1. And we're going to multiply across. We got 3 halves here, so we're going to say it's equal to 3/4 x plus 3 over 2. Okay, and on the left side we got y minus 1 still. Now y minus 1 here, right? I need to add it to the other side, which means I'm going to add a whole number. So I could write 1 as 1 over 1 or 2 over 2. So I'm going to add 2 over 2 to the other side, and I'll add it to both sides. And so our answer is going to be y is equal to 3/4 x plus 5 over 2. Okay? After we're done writing it out, then we're going to graph it. So when I graph it, I'm going to plot my point and plot my line. And are my lines parallel? Did I do it correctly? Yep. Okay, the problem also says, look over here, it also says, hey, look at this point, -2, 1. Is -2, 1 one of the points on my graph right here? Y'all see this point right here? Is it right there? -2, 1. Is that point on my graph? Yeah, so did I do it correctly?
Yep.
Yep. Okay, then we're done. Does that make sense, everyone?
Yes.
Okay, excellent. All right. So I'd like you to do, let's go to 3s now. 3s are talking to their groups of teaching them how to do number 2. Okay, ready, set, and go. Moving on. Number 3, I'm going to ask you to do this with your groups. We're going to do a parallel line, okay? And to this one over here, y is equal to 3/2 x plus 4. I got a question for you. What's the slope that we need to have on our final answer? 3 over 2. What if it was a perpendicular slope? What kind of slope would you have?
-2.
Excellent. Okay, cool. So with your groups now, we're going to have a parallel slope to this line. Y is equal to 3/2 x plus 4. Okay, ready, set, and go. Okay, so the answer here is y equals 3 over 2x plus 6. That's correct, okay? All right? And that will conclude today's lesson.